we start with solution by substitution. There are several ways to solve these systems. We can solve by graphing, by substitution, and by something called eliminating variables. We could use matrices to do so, or there's something called Cramer's rule. Well, all right. Now, graphing, as I'm calling it a Carpenter's solution, because you have to graph a line on a physical piece of paper. And the accuracy of your graph is limited by the sharpness of your pencil, by the smoothness of the paper, the grain of the paper, and the grain of the wood underneath. And you're only accurate as you can eyeball it. A Carpenter's solution, not a mathematician's solution. So we're going to go. This section is about solution by substitution. All right. In solution by substitution, you use one equation to solve for x or y in terms of the other variable. And you substitute that into the other equation, then substitute back for substitute back. All right. So, for example, x plus y equals 10 and x minus y equals 4. From this equation, we'll solve for y. Y, because of this, y equals 10 minus x. And we substitute this expression, 10 minus x, into this equation here. Everywhere we see the y, we replace by 10 minus x. So x minus y equals 4 becomes x minus this, 10 minus x, equals 4. All right, so this is one equation and one unknown, which we can then solve. First, we distribute the negative sign. So you get x minus 10 plus x equals 4. Transpose the 10 to the other side by adding it to both sides. Get x plus x equals 4 plus 10. This simplifies to 2x equals 14. Divide both sides by 2, so x equals 14 over 2. So x is 7. Then substitute back in here, y equals 10 minus x. That's 10 minus 7, so y equals 3. X is 7, y is 3. Or you can write this as 7 by 3. And I do have a request. Please write the whole answer in one place. Don't write x equals 7 in one corner of the paper and y equals 3 in the other corner. It's just more work. Please don't make me work that hard. And please don't make future bosses or colleagues of yours work that hard either. So, okay, put it in one place, mark and indicate where the answer is. It's just easier for everyone, and also forces you to clarity, which is the big thing in that. All right. So, here's some examples. X plus y equals 4, x minus y is negative 6. So from this one, y equals 4 minus x. Substitute into here, x minus 4 minus x is negative 6. Distribute the negative sign, x minus 4 plus x is negative 6. Add 4 to both sides, so transpose 4 to the other side, and get x plus x equals 4 minus 6, so 2x is negative 2. Divide by 2, not negative 2. This should be 4, 2, 3. And so you get x equals negative 2 over 2, so x is negative 1. Plug in negative 1 in for x here. Y is 4 minus negative 1, which is 5. So the solution is negative 1 by 5. This one's very easy. Y equals 3x. Y minus 3x is negative 3. Okay, fine. This 3x is the same as this 3x, which is y. So you get y minus y equals negative 3. Or 0 equals negative 3, which is, manifestly absurd. So therefore, these were parallel lines, and there's no solution. Here, y equals x minus 1, 3x minus 3y equals 3. We'll substitute y minus 1 in for y here. So 3x minus 3 times x minus 1 equals 3. And distribute the negative 3, get 3x minus 3x equals 3. These 3x's cancel and get 3 equals 3, which is true and utterly uninformative about x. And in fact, it doesn't even mention x. So therefore, there are many solutions. These are, in fact, equivalent equations. Let's see now. Okay, here's another one. 2y equals 3x plus 2. 3x minus 2y equals 6. Here's the same 2y here and here. So when you substitute 3x minus 3x plus 2, that equals 6. Distribute the negative sign, 3x minus 2 equals 6.
I have a question.
Yes.
So are you combining both those equations? Because I'm confused as to like what happens to the 2y.
Well, okay, let's say that here's a 2y and here's a 2y, right? So everywhere we see this 2y here, we'll replace it by this here. I could put an intermediary step where y equals a half of 3x plus 2 and plug that in y in here, and you get the same thing as this. Okay, I was skipping a step or two, but
Oh, so you're just plugging in what 2y into that equation.
Into the second one, yes.
Okay.
This 2y is the same as 3x plus 2, so we put a 3x plus 2 into the second equation. So we get this, 3x is canceled, negative 2 equals 6. Again, an absurdity, so there's no solution. These were graphed to parallel lines. Here, x plus y equals 2, y equals x minus 4. Here, wherever there's a y, we can replace by x minus 4. So put in x minus 4 here. So x plus y, x minus 4 equals 2. All right, so transpose the 4 by adding it to both sides. So you get x plus x equals 2 plus 4. So 2x equals 6. Divide both sides by 2. So x equals 6 halves, which is 3. Then plug in 3 in for x here. So y is 3 minus 4. That's negative 1. And the solution is 3 by negative 1. Here we have negative x plus 3y is negative 11. 3x minus y equals 17. Okay, I'll use this first equation to solve for x. So there's a negative in front of the x. That'll cause a bit of trouble, but big deal. First, we subtract 3y and get negative x equals negative 3y minus 11. Multiply by negative 1 and get x equals 3y plus 11. That's equivalent to this first equation. Wherever we see an x here, we're replaced by 3y minus 11. So you get from this turns into 3 times 3y plus 11. That minus y equals 17. Okay, so here's an equation which combines the two equations, combines their information into one equation. That's the idea of substitution. Distribute the 3 over this parenthesis. We'll get 9y plus 3 times 11 is 33 minus a y equals 17. Let's subtract 33 from both sides to move it to the right. Get 9y minus y equals 17 minus 33. This combines on the left to 8y. 17 minus 33 is negative 16. So 8y is negative 16. Divide both sides by 2. Let's get y equals negative 16 over 8, which is negative 2. Plugging in negative 2 for y here. Get x equals 3 times negative 2 plus 11. And after a little bit of work, that's 5. So the solution is 5 by negative 2. Here's an easy one. X plus y equals 2, y equals x. Now this is an obvious substitution where we have y, we can replace it by x. So this becomes x plus x equals 2, 2x equals 2, x equals 1, and since y equals x, y equals 1. Solution is 1 by 1, and yeah, they're equal and they add to 2. Here we have 4x minus 2y equals 8 and y equals 2x minus 4. Okay, we can use this to substitute into here. Wherever we see a y, we can replace it by 2x minus 4. So this equation becomes 4x minus twice 2x minus 4 equals 8. So you distribute the negative 2. 4x minus 4x plus 8 equals 8. 4x is canceled. 8 equals 8, that's true, but it says nothing about x, so there are many solutions. That's also called underdetermined, whereas when there's no solution, that's called overdetermined. Oops, did I do this? Oh, yes, I was doing solutions from 4.1, now we go to 4.2. Oh, yes. The book asks to, in section 4.1, to solve by graphing. Please don't. Solve by substitution, or even better yet, by elimination, or even Cramer's rule, if you can. We have y equals 2x and x plus y equals 6. So we substitute 2x for this y here. Get x plus 2x equals 6. There that goes. Therefore, 3x is 6. Divide by 3. X equals 6/3. That's 2. Y is twice that. Y is twice 2 is 4. 2 by 4. And that is the solution. And indeed, 4 is twice 2, and these add to 6. X plus 3y equals -4. X equals -5y. That's pretty simple. Plug in a -5y wherever we see an x here. So this becomes -5y plus 3y is -4. The left is there simplifies to -2y. That equals -4. Divide both sides of this equation by -2 and get y equals -4 over -2. That's 2. X is -5 times y, so that'll be -5 times 2 is -10. And the solution is -10 by 2. Oh, and yeah, I note that here I first found y and then x. In the ordered pair, it's x and y in alphabetical order. Do try and keep the order straight. Occasionally people get mixed up about that. 4x plus y is -15. 2x plus 3y is 5. From this first equation, we can isolate y by transposing 4x, subtract it from both sides, and get y equals -4x minus 15. We can substitute this y in here in the second equation to get 2x plus 3 times -4x minus 15 equals 5. All right, distribute the 3, get 2x minus 12x minus 45 equals 5. Move the 45 to the right by adding it to both sides. 2x minus 12x equals 5 plus 45. Okay, left is -10x, right is 50. -10x equals 50. Divide both sides by -10. Get x is 50 over -10, which is -5. And y, we'll substitute a -5 in here. Y equals -4 times -5 minus 15. And after a bit of work, that's 5. Solution is -5 by 5. Six minus y equals 4x. 2y equals -8x minus 20. Now this one, well, these coefficients are all even, so let's divide by 2. And when you divide throughout, you get y equals -4x minus 10. Now we can substitute in that y into here. Get 6 minus y, which is -4x minus 10, equals 4x. 6 minus -4x minus 10 equals 4x. Try distributing the negative sign. 6 plus 4x plus 10 equals 4x. Okay, let's move the 4x to the right by subtracting. 6 plus 10 equals 4x minus 4x. Uh-oh, the 4x entirely cancel, and we're left with the equation 16 equals 0, which is not true. So there's no solution. Here you have y minus 3x is -5. 21x equals 7y plus 35. The first equation we can solve for y by transposing the 3x. So y equals 3x minus 5. That's equivalent to this. This 3x minus 5 we can then substitute into here in the other equation. So you get 21x equals 7 times 3x minus 5 plus 35. Distribute the 7. 21x equals 21x minus 35 plus 35. Transpose the 21x to the left. So you get 21x minus 21x equals -35 plus 35, or 0 equals 0. Again, true, uninformative. Therefore, these are really only one equation's worth of information, and there are many solutions. A plus b equals 1. A minus 2b is -1. From the second equation, we transpose the 2b and get a equals 2b minus 1. Substitute that into the first equation and get 2b minus 1 plus b equals 1. And so 3b minus 1 equals 1. Add 1 to both sides. 3b equals 2. Divide by 3. b equals 2/3. And then to solve for a, we put 2/3 in for b. A equals 2 times 2/3 minus 1. That's 4/3 minus 1 is 1/3. So the solution is 1/3 by 2/3. Here, 53. X plus 2y is -6 and x equals y. Well, that's a pretty easy one. Wherever there is a y, we replace it by x. So the first equation becomes x plus twice x equals -6. So left side simplifies to 3x. That equals -6. Divide by 3. X equals -6 over 3, which is -2. And y is the same, -2. Solution is -2 by -2. And we have x equals 7y minus 10. And 2x minus 14y plus 20 equals 0. All right, so we use this here to substitute this wherever there's an x here. And that combines the equation to this. Twice 7y minus 10 minus 14y plus 20 equals 0. Distribute the 2. 14y minus 20 minus 14y plus 20 equals 0. Left side, everything cancels out, and you get 0 equals 0. Not much information left there, none about x or y. So there are many solutions. Again, these are basically two equivalent equations, not enough information. All right, let's stop this recording.